Hey you, did you ever wonder about how our sun and planets form? Relatable, right? But to answer this question, we must go back 4.6 billion years ago. It all starts as a nebula, a big, cold, dense cloud stretching light years, composed of mostly hydrogen and helium, with solid tiny particles called pre-solar grain, also known as stardust. After billions of years of particles colliding in the center of the nebula, clumps start to form, and gravity gets stronger in that region, pulling everything inward, eventually collapsing and heating up, converting gravitational force into heat by accelerating particles and eventually increasing their potential energy, which can be converted into kinetic energy upon collision, forming a protostar. This is the sun in its earliest form. As the gravitational pull of the protostar strengthens, the rest of the nebula flattens, forming a disk called the protoplanetary disk, the birthplace of the planets. After the core of the protostar eventually heats up because of the collisions in its core, going up to around 15 million degrees Celsius, the hydrogen atoms squeeze together until reaching a state of plasma, forming helium and releasing a great amount of energy. This is called nuclear fusion. This marks the start of the second phase of the sun's life. Note that nuclear fusion counterbalances the gravitational pull of the core of the star. This is why stars don't just collapse on themselves. Also note that other types of stars may go through different phases through their lifetimes. Scientists theorize that planets start as particles, even smaller than a grain of sand, in the protoplanetary disks surrounding newly formed stars, starting as particles and gaining mass and consequently gravity as they collide with other particles. These planetesimals form visible rings in the protoplanetary disk by collecting the debris in their orbit around the Sun, ultimately becoming planets.